Okay, today for 9.3 we're going to look at sample spaces. And so we have to find the probability of tossing a head on one toss of a fair coin. So when I toss the coin, I have two things that might occur. I might either get heads or tails, and we can write a tree diagram of that. Now, the next thing I want to do is consider two heads and two tosses of fair coin. So on the first toss, I get heads or tails. On the second, I get heads or tails. So my sample space would be heads, 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 tails, tails, heads, and tails, tails. And so the probability of getting tails, tails is 1 out of 4. If we look at our first example, it will be 1 out of 2. So the third thing that we might consider is rolling a fair die. Or no, I'm sorry, drawing 4 queens from a deck of 52 cards. So there are 4 queens in a deck, and there are 52 cards. So the probability of drawing a queen is 4 over 52, which reduces down to 1 over 13. And so in all three of those scenarios, the way that we calculated the probability of an event occurring was to take the total number of outcomes of the event occurring over the actual sample space. And so we could write it this way: the probability of an event occurring is equal to the number of outcomes of the event over the number of outcomes of the sample space, or all possible outcomes is another way that you could look at that, where E equals the event and S represents the sample space. So let's look at another example from the textbook, and we'll try to calculate the probability of a certain event occurring. Okay, so in example number 2, what we are asked to do is find the probability of rolling a sum divisible by 3 of 2 die in a single roll. So I'm going to have 2 die, and I'm going to roll them, and I'm going to sum up the numbers that the dice give out, and then I'm going to figure out what that sum is, the probability of that sum being divisible by 3. So on the first die, I can roll 1, 2, 3, 4, 5, 6. On the second die, I can roll 1, 2, 3, 4, 5, 6. If I make a chart like this and then I add the sums, 1 plus 1 is 2, 1 plus 2 is 3, and so on and so forth. In the grid, I'm just going to fill out the sums of the 2 die. And now what I'm going to do is try to figure out what's divisible by 3. So I'm going to circle 3 is divisible by 3, 6 is divisible by 3, and 9 is divisible by 3. And so if I add all those up, I get 12 out of the total number of outcomes, which is 36, which reduces down to 1 out of 3. So the probability of me rolling a number that is divisible by 3 is 1 out of 3. Sometimes it's easier if we can find an equation that will help us calculate the probability. So one of our goals is to write an equation that gives us the probability of an event occurring. However, in the next example, we'll see that those equations are not always accurate. So example number 3 suggests that we can weight a die. That would mean that it is not fair. And they say that they offer an equation that will give us the probability of an event occurring. And so n represents the number that's weighted or more likely to occur when we roll the die, and the equation is equal to 1 over the quantity n squared plus 1. So if my outcome of 1 occurring, in other words, if I let n equal 1, the probability is 1/2. If I let n equal 6, then the probability is 1 over 37. Now, if I add all of those probabilities up, it's going to be greater than 1, so the total does not equal 1. So what does that mean? Well, if we go back and look at every example we've done up until this point, we'll see that all of the sums should equal 1. So in our first example, the probability of me getting a head on the toss of a fair coin, I have a 1/2 chance of getting heads, 1/2 of tails. When I do 2 tosses, I have 1/4 plus 1/4 plus 1/4. With the die, I have 1 out of 36, but that's 36 probabilities or possibilities. And so in every single case, when I add up all the probabilities, the total sum is 1. Here it is not 1, therefore the equation is not valid. In other words, that equation will never work. So that's how we can double check the validity of an equation that helps us approximate or calculate the probabilities of an event occurring. Okay, in example number 4, what we are going to do is, again, we're going to try to find the probability of a specific event occurring. And so we're going to need to calculate the probability of, well, let me say what the problem is, and then we'll go from there. If I have 12 chocolates and 4 of them are vanilla, what's the probability of Jamar picking 2 vanilla covered, chocolates with vanilla in them? So we're going to let Jamar choose 2 candies out of the 12, 4 of which have vanilla. What's the probability of when he chooses 2 that both of them will be vanilla? So the first thing we need to do is calculate the sample space, and the sample space is we're going to choose 2 things out of 12, and so that's a combination. So 12 choose 2 would be 66, and that's our sample space. Now the next thing we would need to do is figure out the total possible outcomes of the event choosing vanilla. And so remember that we're going to have 4 vanillas and we're going to choose 2 of them. So once I've calculated the sample space, the next thing I need to do is calculate the total outcomes of the event occurring, which will be 4 choose 2, which is 4 factorial over 2 factorial over the quantity 4 minus 2 factorial, which is 6. So the probability of this event occurring is 6 over 66, or 1 over 11.